Unit 2, Worksheet 5, Multiple Representations of Motion. Problem number 2. Problem number 1 gave us the position versus time graph and then asked us to fill in the velocity versus time graph, the written description, and the motion map. Problem number 2 is instead giving us this velocity versus time graph, and we need to work backwards in order to figure out the position versus time graph. Then we can describe the object's motion in words and have a motion map. So one thing that I am seeing in this first region is I know that for my velocity versus time graph, that horizontal line that's labeled T, that's going to be my x-axis, and that's how we know what time it is. Everything underneath that x-axis is going to be a negative value, negative velocity. Everything above that is going to be positive velocity. So I can see in this first region of the graph up until this arrow, I have a negative velocity. And because that negative velocity is all the way down here, I know it's going to be a pretty steep slope. So I'm going to start off with a pretty high y-intercept, and I'm quickly going to go down in a straight line. That's going to be one constant slope that has a negative slope, which is how we know that on a position versus time graph, that's how we can represent a negative velocity. Then this next region, between these two lines, we have a positive velocity that does not change. However, this positive velocity is not going to be as steep as our negative, so I'm going to have a much more shallow positive slope. And then the third region of our graph, right over here, it looks like our object has a velocity of 0. So wherever position I am at, I'm just going to have a horizontal line. Oh, that is an ugly horizontal line. So I start off with a negative velocity, which is what I have over here. Then I have a shallower but positive velocity, which is represented here. And then I have a horizontal line when my position does not change, which indicates that my velocity does not change, and that velocity should be 0. Now that I have my position versus time graph drawn out, that's going to make it really easy for me to describe this object's motion in words. The object starts at some positive velocity, at some positive position. And because the position decreases, I can say, and travels left for some time. The next region of the graph is where the position starts to increase. So the object then travels to the right more slowly. For it looks like it's the same period of time. And then the last region of the graph. The object comes to a rest for some period of time. Now, I don't know exactly what this final position would be, so all I can say is it would have a positive position if I were to include that in my written description. Now, the last way to represent this object's motion is with our motion map. And that's why I like to have my position versus time graph drawn from my velocity versus time graph, because it makes it easier for me in order to be able to plot that data on my motion map. So this number line right here, it's going to be for our position. We start off with 0 meters, and as we travel to the right, it becomes more and more positive. So I'm going to begin somewhere high up on my motion map, where I have 0 seconds, because I need to travel to the left pretty far. So it travels to the left with a big velocity, and that's going to happen let's go for just 2 seconds of travel to the left. So at 2 seconds, it's going to be here. However, if I were to leave it here and attempt to draw my arrow immediately going the other way, it would overlap with my previous velocity vector. So what I will need to do is I will need to drop down that 2 second interval in the same position, but just underneath where it would go. So that way I can indicate my velocity is now going to be traveling in the opposite direction. And then if I said it was 2 seconds to travel to the left, it looks like I have to say it's 2 seconds to travel to the right. So then I will need to end up with those last 2 seconds of rest time down here. So I have 1 second and 2 seconds of travel to the left, which is why at 2 seconds it is at this position. Then 2 seconds of travel to the right, which is why at 4 seconds it's this position. And then it stops for 1 second here, stops for another second there. And we will end at 6 seconds.